A coin is kept inside the water of refractive index 4/3. When viewed from air in a vertical direction, appears to be raised by 2 mm. Find the depth of the coin in the water. Okay, now a coin is kept inside the water. The refractive index of water is 4/3. Let this be a beaker containing water. And when viewed from vertically above means, suppose someone is viewing the container from here. Okay, it is a direction in which they are looking at the coin. Someone is looking at the coin. Appears to be raised by 2 mm. Suppose the coin is placed initially at the bottom of the beaker. Okay, this is the actual position of the coin. And when the person looks from vertically above, the coin appears to be raised by 2 mm. Now the coin is appear to be placed at this point and it is raised by 2 mm. Okay, so the height by which this coin is being raised is called shift. Okay, the shift out here is 2 mm. So first I will start with given shift is 2 mm. Now, so what is the question? Find the depth of the coin. So suppose this is the water and this is the depth of the coin, which is also called real depth. Okay, the depth of the coin is called real depth. And since the coin is raised by 2 mm, the coin is raised by 2 mm, so this apparent position is called apparent depth. Okay, actual depth, real depth. Because of refraction, the coin is being raised by 2 mm, and this depth is called apparent depth. And we all know shift means real depth minus apparent depth. This shift is real depth minus apparent depth. Now I'll write down out here, or real depth minus apparent depth equals to 2 mm. Okay, I'll write it as equation number 1. Again, one more thing is given. Refractive index of water is given. Let me write it like this. Refractive index is given, which is 4/3. Okay, now we know the formula, since refractive index equals to real depth by apparent depth. Okay, refractive index in terms of real depth and apparent depth is refractive index equals to real depth by apparent depth. Now, what is real depth from here? Therefore, real depth equals to refractive index into apparent depth. This real depth equals to, this will go up, cross multiplication. Real depth equals to apparent depth into refractive index. Now I will put this value in equation number 1. I'll put this value in equation number 1 out here. I'll put this value of refractive index out here. So therefore, in place of this refractive index, what will I write down? I'll write this. Refractive index into apparent depth, there is minus apparent depth equals to 2 mm. Okay, now what is common out here? Apparent depth is common out here, so what will I do? Therefore take a common. Apparent depth equals to refractive index minus 1. Sorry, not equals to. There's a I'm taking out common, so no equals to. Apparent depth, bracket open, there is refractive index remaining out here minus 1. Nothing is out there, so 1 equals to 2 mm. Or now put the value of, okay, now I'll just keep this apparent depth on one side. Apparent depth equals to, this 2 mm will be on their own side, this thing will go down. Okay, since there is nothing in between, it means multiplication. So when it goes to the other side of the equals to sign, it will go down as a division. So mu minus 1. Or apparent depth equals to 2, put the value of refractive index 4/3 minus 1. Now I'll take the LCM of this. Or apparent depth equals to 2 by LCM is 3, because this is 1. Okay, LCM of 3 and 1 is 3. 3 is already there, so 4 minus 1 into 3, 3 into 1, 3. Okay, this is basic mathematics which you have to know by yourself. Or apparent depth equals to 2 divided by 1 by 3. Okay, or apparent depth equals to, this 3 will go up, 2 into 3 by 1, okay, equals to 6 millimeters, since we are doing the numerical in terms of millimeters. So apparent depth is 6 millimeters. So let us go to the diagram. So this apparent depth which I got is 6 millimeter, but the question is asking find the depth. Depth is apparent depth plus the shift. So I'll continue out here. Therefore the depth of water or real depth equals to shift plus apparent depth, because this is real depth, sorry, apparent depth, and this is shift. If we add these two, we will get real depth. Okay, equals to shift I got 2 millimeter plus apparent depth I got 6 millimeter equals to 8 millimeter. Therefore the depth of coin inside water or in water, let's write in because it is in question. The depth of coin in water is 8 millimeter. Okay, this is your answer. A coin is placed at the bottom of a beaker containing water with refractive index 4/3 at a depth of 12 centimeter. By what height the coin appears to be raised when seen from vertically above? Again same thing, there is a beaker containing water, okay, with refractive index 4/3. The refractive index of water is 4/3. One thing which I would like to tell you is, remember, thickness is always same as real depth. Okay, the thickness from here to here is same as the real depth, so to keep this thing in mind. Whenever they say, there might be some question in which they say the thickness of the slab is something, when they say thickness it means real depth. Okay, a coin is placed at the bottom of a beaker containing water with refractive index 4/3 at a depth of 12 centimeter. Okay, if this was glass slab, the thickness would have been 12 centimeter. Okay, like that. So the depth of water is 12 centimeter, which means this depth is 12 centimeter and a coin is placed out here at a depth 12 centimeter. By what height the coin appears to be raised when seen from vertically above? Again, if someone is looking from this direction, by what height the coin appears to be raising? Okay, what is the height? Let the coin appears to be at this point. Now let us assume the coin appears to be at this point. So the height by which this coin is being raised is x centimeter. Okay, the height by which the coin is being raised is x centimeter, and this is called apparent depth, and this is my real depth. Okay, now let us go back to the question. What is given? Given real depth equals to 12 centimeter and refractive index is how much? 4/3. Okay, so first my task will be to find apparent depth. My first task will be to find apparent depth. Now I'll use the formula, since this we have already done in previous numerical. Since refractive index is real depth by apparent depth, therefore apparent depth equals to real depth by refractive index, which is equal to, real depth is 12 centimeter by refractive index is 4/3 centimeter. Okay, since we are calculating apparent depth, equals to 12, this 3 will go up into 3/4 will be in its own place. 4 1s are 4, 4 3s are 12. So 3 into 3, 9 centimeter. So my apparent depth will be 9 centimeter, which I have got this 9 centimeter. My apparent depth is 9 centimeter. Now I'll calculate the shift. The formula for shift is shift equals to real depth minus apparent depth, and I've already told you the shift we have considered x out here. Therefore x equals to, real depth is 12 minus apparent depth is 9. Therefore x is 12 minus 9, which is equals to 3. Therefore the coin is being raised by 3 centimeter. So let us check out here. The coin was placed at a depth of 12 centimeter and the refractive index was 4/3. So using the formula, refractive index is real depth by apparent depth. This was given, we found this. Okay, this was given, so we found apparent depth and we got 9 centimeter. And using the formula shift equals to real depth minus apparent depth, we found the shift. Okay, x centimeter with the given we had written that let x be the shift. So the x which we got out here is 3. So the shift is 3 centimeter and the coin is being raised by 3 centimeter in this case. 9 plus 3 is 12. Now this numerical is verified.